Hey guys, in this video we're going to be covering Target 4A.2. Our mastery learning objective is I can interpret a table to identify the max height, initial height, distance traveled, and the duration of time by using key features of real-world parabolic functions. So for this, still same vocab as the last video, x-intercept, y-intercept, vertex. So kind of what does this key feature tell you in terms of a real world problem? So that's the big key here. Now we're talking about real world problems. So our x-intercept, y-intercept tells us a little bit something different. The values, the way you find them is still the same, but you just have to put it in context of the problem. So an x-intercept, this tells you this is the starting point. So starting point, sometimes, because sometimes the x-intercept is negative, and we don't have negative concepts in real world, right? You can't have negative time, but it will always be the stopping point. Right, so that's important. It's this x-intercept. Think of, real life parabola. If it's going like this x-intercept, right? This x-intercept right here would be negative, right? And then this x-intercept would be positive. So in this case, that x-intercept, that starting point, we wouldn't consider that one because we have to do it whenever time is equal to that 0. So this is why real life problems are a little bit different than when we're dealing just with x-intercept, y-intercept. Y-intercept, what it tells us in real life is that this is the initial height, right? Initial just means the start. So it's the start height. You can think of the height the object starts at. Right? For example, if we have that parabola, the initial height, well, this would be my y-intercept right here, right? This would be my y-intercept. And that would tell you however high our object is being thrown or wherever you launched it out. Our vertex, what does our vertex tell us? This is just either our max or our midpoint. Oops, sorry. So the max or the minimum, right? It can't be both. It's either the maximum height or the minimum height. Right? If you have a maximum height, the parabola is going to look like this. The vertex is going to tell you wherever that max is at. Versus the minimum, our vertex is that lowest point, so it would tell us what that lowest height is. All right, so let's look at our first example here. It says example 1. The following graph shows the height of a ball being thrown. So this is a ball, and the first question says, well, what is the initial height? The initial height is our y-intercept, right? Initial height. This is talking about our y-intercept. And where is our y-intercept? Right here. So the initial height then is going to be at, right, 0, 3, which means 3 feet. All right, let's just assume here that our units on our y-axis, you will typically have units, but let's say that this is feet and that this is seconds. All right. Part B, when did the ball hit the ground? Well, when did it hit the ground has to be positive values. So this again is when it hit the ground. This is talking about an x-intercept. Wherever it hit the ground, well, it hit the ground right here. And this is at 3, 0. So therefore, when did it hit the ground? When is a time, right? Well, at 3 seconds. how long was the ball in the air for? So this is our stopping minus our starting. So if this was where it hit the ground, we have to use it whenever time is 0. Okay, so I know that there's not a point there, but that's where it started off at. So we have to use our stopping point minus our starting point. Now you would use whatever starting point if it was positive or if it actually is at 0, but since the other x-intercept is over here and it's negative, you can only use where time starts, right? Time starts at 0. So our stopping would be at 3, and our starting, well, time always starts at 0, unless otherwise our graph was shifted a little bit to the right, which means it was in the air for a total of 3 seconds. Part D, what was the maximum height of the ball? So this is talking about where is that vertex, right? Our vertex seems to be right here where that highest point is. And this is asking for the y value. It's asking you for the height. That's our y value. So this would be 4 feet. Right? So it's 4 feet in the air. That was my y value right here for this vertex, which is 1, 4. All right, scrolling on up here. When did the ball reach its maximum height? So this is still the vertex, right? Still asking for the vertex, but when is referencing the time. So at what time did it reach that maximum height? So this is going to be the x value, and our x value is going to be at 1 second. All right, so that's a couple things. What was it? The height, talking about the y value. When is talking about our unit of time here, right? That's our x-axis. So always make sure that you know what the x and the y-axis is indicating. Let's look at example number 2. The following example shows the height of a ball being kicked. All right, so the first thing is look at our x and y axis. Something that I want to label right here for you guys is that our initial height, we're going to say that this is in meters this time, represented by m. And our time, we're still going to use time, and that's going to be measured in seconds. All right, so the first question, what was the initial height of the ball? So initial height, again, is talking about the y-intercept. And our y-intercept is down here. So where does our ball start? Well, it's starting off on the ground. So that means at 0 meters. Right? If you want to kind of put, in parentheses here, right? It's on the ground. Right? Our height starting off at that 0. When did the ball get kicked? Right? So it starts at our x-intercepts. Right? When did it get kicked? That would be our starting point. So it's going to be our starting x-intercept there. Well, our x-intercept is also right around here. So that's going to be at 0 seconds, right? So in time hasn't started yet. When did the ball land on the ground? This is going to be still our x-intercept, but this is our stopping x-intercept, or our end x-intercept, which would be when it hits the ground over here, and that would be after 8 seconds. How long was the ball in the air? This is going to be our stopping minus our starting. Notice our starting has its own value of a 0 because its parabola did not go negative. So 8 minus 0, still going to be 8 seconds. What was the maximum height of the ball? So maximum height is referencing that vertex point. And our vertex here is going to be wherever we find that highest point. When it's asking you what the height was, our height is talking about that y-axis. So if this vertex point is at 415, we want the height, which would be that y value. So this would be 15 meters. When did the ball reach its maximum height? this is still talking about the vertex, but 1 is asking for the time. So therefore, that's our x value of our vertex, which is 4. So this is at 4 seconds. Right? Make sure you're reading closely to what these problems are saying, and it's always nice to just annotate what you have already for you. Looking at the next example, example number 3. It says the following graph represents the height of a dolphin jumping out of the water. So a couple things here, just so that we kind of annotate our x-axis and y-axis. This is going to be, obviously it's our y, and this we're going to be measuring in yards. To switch up the units, right? So typically see YD as our x-axis, or our y-axis. Our x-axis, we're still going to be measuring time, and this is still going to be in seconds. All right, so when did the dolphin leave the water? So assuming that that x-axis is our water line, when did it reach out of the water? So this is going to be our starting x-intercept, which wherever it jumped out of the water is right here, and that would be at 1 second. All right, when did the dolphin land back in the water? So this is our stopping x-intercept. And, right, our dolphin jumps up in the air, comes back down, lands right here, and that would be at 7 seconds. How long was the dolphin out of the water? Well, we take our stopping point, and we have to subtract our starting point. So therefore, it's going to be 7 minus 1, which is 6. So our dolphin was out of the water for a total of 6 seconds. What was the maximum height of the dolphin? So maximum height is asking for our vertex. And if it's dealing with height, this is going to be our y value, right? So this vertex is our highest point. That is at 4, 6. Height is measured by the y-axis, so therefore it's going to be 6 yards. When did the dolphin reach its maximum height? So still dealing with the vertex here, but it's asking us for our x value, right? This is our vertex. This is going to be our x value. Why? Because when means time, and time is our x value. So our x value of our vertex was 4, so therefore at 4 seconds, our dolphin reached its maximum height. All right, that brings us to the end of this video. Go ahead and work on activity 4A.2. Good luck.